Dear students, welcome to lecture 2 in Unit 4 Influence Line for Indeterminate Structures. So today we are going to see a problem. The given problem is draw influence line for reaction at B and for the support moment MA at A for the proper cantilever shown in the figure. They have given in the figure that we are having a proper cantilever beam. So we know that the indeterminacy for the proper cantilever is 1, and also we need to calculate the ordinates at 1.5 meter intervals. So first we are going to calculate the reaction at reaction at B. So we know that the general formula, as per the Mueller's principle, is we need to remove the constraint at first condition, remove the constraint at B. So what we need to do, the point where we are going to find out the value, we need to remove the constraint at that point. So if you take B, we are having a roller support here. So we are going to remove the roller support and we are going to create a force here. Second point, what is it? We are going to apply, we need to apply unit displacement. So instead of applying unit displacement, what we are going to do is we can also apply unit force and find the corresponding displacement. So what we are going to apply instead of applying the unit displacement, we are going to apply the unit load and we are going to find the corresponding displacement. So if you take the diagram, then it will be like this. First I am going to remove the load. So instead of load, I am going to apply, remove the constraint. First step I have done it, and what I am going to apply the value, that is RB equal to 1. So if I apply like this, so when we apply the unit force, then we will have a displacement like this. So we can take this displacement as YBB, because at B the displacement is happening. Remember, we need to only remove the constraint which will control this upward reaction alone. So here if you take, since it is a roller support, it will allow the rotation and the horizontal displacement. So it will control only the vertical displacement. So only I have removed the total support and I have introduced a load, that is RB equal to 1. So since RB equal to 1, we can calculate the moment. We know the condition, that is moment equilibrium equation, that is mx equal to EI d square y divided by dx square. So this formula you have known it from your previous strength of materials. So next what I am going to do, I am going to calculate the moment m equal to, let us consider x at this distance. Let us consider x at this point. So we can take this point as x. So this will be the x distance. So here we can say it as yxb, that is displacement at y due to load at B. So mx will be equal to, we can write it as RB into x, because I am going to find out the value at this point. So I can take it as RB into x. Since RB value is 1, so we can take it as x. So what I can write is d square y divided by dx square, EI. We are going to equate these two. So equal to x. So if I differentiate, then the value will be dy by dx equal to, EI minus EI equal to x. What I have done is, I have done the differentiation. So if you done the differentiation, not differentiation, I have said it wrongly. We are doing the integration. Upon integrating, so we know that we will get it as x square by 2 plus C1. That is, I am shifting this minus 2 here. I can write it as EI d square y divided by dx square equal to minus x. So I am integrating this equation. So I will get minus x square by 2 plus C1. Again upon integrating, I will get it as EIY. Because why I am doing this is, I need to find out the deflection y. So EIY equal to, again I need to integrate this, then the value will be x cube divided by 3 into 2, so the value will be 6 plus C1x plus C2. This C1 and C2 is nothing but the constant, so we need to find out the value of this C1 and C2. So in order to find out the value of C1 and C2, we can say that at x equal to 0, the value of y will be equal to, at x equal to 12, here if you take it at this point, then the value of y will be 0 because there will be no deflection at the fixed end, so the value will be 0. So if I substitute here, then the value will be C2 equal to 0. If you take x2, xc2, here the value will be, here the total value will be 0 equal to x cube, that is minus 12 the whole cube divided by 6 plus 12 C1 plus C2. So if you substitute, then the value will be, what we will get is, so we can have this as a one equation. Then at x equal to 12, we know that the dy by dx, that is deflection, not deflection, slope. Here also we can say that since it is a fixed support, the deflection value will be, the slope value will be 0. So if you substitute in this equation, that is we are going to substitute in this equation, so we know that we can say that the value will be 0 equal to minus 12 square divided by 2 plus C1. So if you substitute, then the value of C1 will be 72. And if you substitute the value of C1 in this equation, we will get the C2 value as, so if you substitute the value of C1 in this equation, then we will get the C2 value as minus 576. So we have calculated the value of C1 and C2. So next what we are going to substitute in this equation, that is, what I am going to do is I am going to rewrite this equation. That is, if you see here, we are having the equation EIY equal to, so what I am going to do is I am going to rewrite the equation EIY equal to minus x cube divided by 6 plus 72x minus 576. So this is the equation which we got for the deflection at B. So at B means we can say that the value of x will be 0. Then the value will be maximum for y. So what I am going to substitute here y equal to, that is EIY equal to minus 576, because we know that at x equal to 0 y will be maximum, at y equal to, at x equal to 0 y equal to y max or ybb. So we need to find out this ybb. So I have substituted ybb here. So ybb equal to minus 576 divided by EI. So this is the value at ybb. If I want to calculate the value at yxb, what I need to do, I am going to substitute the formula. So I can say that influence line ordinate ILO for RB, that is reaction at B, at x distance will be equal to, we can say that the formula is yxb divided by ybb. So we know that the yxb value is this because we have calculated the value for this x distance only. So we can say that yxb is minus x cube divided by 6 plus 72x minus 576 into 1 divided by EI divided by minus 576 divided by EI. So this is the value which we are getting. So if you simplify this, then the value will be minus x cube divided by 6 plus 72x minus 576 divided by minus 576. So this is the formula for RB at x. So we have calculated the value. Next what we need to do, we need to calculate the value at every 1.5 meter interval, because that is what they have asked us to do. So what I am going to do, I am going to split the value, that is x, and I am going to take RB. So x first I am going to take at 0, that is I am starting from the point B. So 0, 1.5, 3, 4.5, 6, 7.5, 9, 10.5 and 12. So what I am going to substitute the value of x here. So if I substitute 0, then we know that we can get the value of 1. Next, if I substitute 1.5, the value will be 0.814. If I substitute 3, the value is 0.632. And if you substitute 4.5 in this equation, we will get the value as 0.463. If you substitute the value as 6, then the value will be 0.312. And if you substitute the value of 7.5, the value will be 0.184. If you substitute the value of 9, then the value will be 0.085. If you substitute 10.5, then the value will be 0.022. If you substitute the value of 12, then the value will be 0. Because if you see here, 0 is at B. So we are substituting the unit load at B. So the reaction will be maximum 1. And if you take the point A, we know that it is a fixed support, there will be no reaction. So the value will be 0. So this is how you need to calculate the value. Next, what we are going to do, we are going to draw the influence line diagram for the given problem. So I am going to mark it here. So this is the 12th meter, so the value will be 1. Next, what I am going to, I can say that I am marking 0 here. Next, 0.022, that value will be here. Sorry, this will be very small, and 0.085 like this. Again 0.184, 0.312, 0.463, 0.632, 0.814. So if you join, then the value will be like this. So if you draw properly, then the value will be like a curve. So this is nothing but the ordinates. So this is the influence line diagram for propped cantilever beam for reaction RB. Next, what we need to do, the second condition they have given is, we need to calculate the moment at A, that is MA. So in order to calculate the moment, we know that the condition is, first condition is we need to remove the constraint. So remove the constraint at A. That is, constraint means the constraint which will control the rotation alone. So if you take the value, then we need to remove only the rotation. So what I can say is, let us consider the beam like this. So what I am going to do is, I am going to introduce a hinge here. So this hinge will allow the rotation. So what I am going to do, I am going to apply a unit moment, because if we are going to calculate the reaction, then we need to apply the unit force. If we are going to calculate the moment, then we need to apply the unit moment. So what I am going to do is, I am going to give a value of MA equal to 1. So I am applying a unit moment. So we can say that here we are having a roller support. So if you calculate, then the value will be like this, right? So this can be your theta A, that is theta AA at A. So if I am going to say that I am going to calculate the value here, that is at distance of X, here we will have the value of Y X A, that is displacement at X due to the force or moment at A. So we can say that we are applying a unit moment, that is MA equal to 1. So we know the equation mx equal to minus EI d square y divided by dx square. This is the formula. So if you want to calculate the reaction, that is RB equal to, we can say that the value will be minus RA. It is equal to 1 by 12. That is, we can say that if you take the moment about this point, then we can say that RB into 12 plus 1, because RB will be in anticlockwise direction. Here we can say that RA will be, RB in anticlockwise direction minus plus 1 so equal to 0. So we can say that RB equal to 1 by 12. So we know that RA plus RB should be equal to 1. So if you substitute the value, then the value will be RA plus RB. That is, there is no load acting on this point. So RB is positive means then RA need to be negative. That is only mentioned here. So next what we need to do, we have calculated the mx. Next what we need to do, we need to, as usual, we need to calculate the value. So here if you take, then the value will be, we can say that as, so next what I need to do, I am going to find out the mx moment. So mx means we can say that RB into x. So RB into x. RB value is 1 by 12. So we can say it as x by 12. So we have calculated the moment. What we need to equate this. So EI d square y divided by dx square equal to minus x by 12. So again what we need to do, we need to find out the displacement, because our ultimate goal is by applying the unit moment or unit force, we need to calculate the deflection caused due to it. So what I am going to integrate this equation. So if I integrate this, then the value will be EI dy by dx equal to minus x square divided by 24 plus C1. If you see here, I have integrated this. So x will become x square by 2. So already we are having 12. So the value will be x square divided by 24. Next, upon again integrating, EIy equal to minus x cube divided by 72 plus C1x plus C2. So what we need to do, again we need to, at x equal to 0, we can say that the deflection value will be 0, and at x equal to 12, the deflection value, that is y value, will be 0, because since we are calculating the moment, we can say that if you see in this diagram, at x equal to 0, the deflection, that is y value is 0, and at x equal to 12, the deflection value is 0. That is what I have substituted here. So if you substitute in this equation, then we can say that the value of C2 will be 0. And if I substitute 12 in this equation, then I can calculate the value of C1. So if you substitute in this equation, then the C1 value will be 2. So I have calculated the value, that is EI y xa equal to minus x cube divided by 72 plus 2x plus 0. So this is the equation. So I can say that since I need to find out the moment, that is I need to find out this theta AA, that is the displacement at this moment value. So in order to find out that, what I need is I need to find out dy by dx. It is nothing but theta ax or theta xa, that is displacement or slope at point x due to the moment at A. Because since in previous step we need to calculate the force, so we have calculated the, directly we have calculated the reaction force. Here we need to calculate the moment, so we are going for the rotation. So theta xa, it will be equal to, so the equation is, we know that 1 by EI. If I differentiate this, then the value will be x cube will become 2x square divided by 72 plus 2, here minus. So thus if you simplify this, then the value will be 1 by EI minus x square divided by 3x cube here. So the value will be 24 plus 2. So this is the equation. So again what we need to do, we need to calculate theta AA, because we need to compare the value. So if you calculate the theta AA value, then that is at x equal to 12. So the theta AA value will be, if you substitute x equal to 12 here, then theta AA will become minus 4 divided by EI. Because what we need to do, we are going to apply x equal to 12 in this equation. That is at x equal to 12 means the value of theta xa will become theta AA. So if you substitute in this equation, then the value which we will get is this. So as usual, we know that if we want to calculate the influence line ordinate at MA, we need to consider the value as, that is theta xa divided by theta AA. So if you substitute in this equation, then the value will become x square divided by 288 plus since we need to calculate the yxa, that is deflection, so we are taking yxa. So what we are going to do, we are going to substitute in this equation. So if you substitute in this equation, then we will get it as x cube divided by 288. Since it is minus, minus into minus will get plus. Here minus x divided by 2. So this is the equation. So again what we need to do, x. Next here influence line ordinate. So here 0, 1.5, 3, 4.5, 6, 7.5, 9, 10.5 and 12. So if you substitute the value of 0 here, then we will get the value as 0. Here minus 0.738, minus 1.406, here minus 1.934, here value will be minus 2.250, here the value will be minus 2.285, here the value will be minus 1.969, and here the value will be minus 1.230, and here the value will be 0. So if you substitute in this equation, remember if we want to calculate the reaction, then we need to consider the y value, that is deflection at point required and at the x distance, and we need to compare the value. That is, if you see here, we are going to compare the at a x distance yxb divided by ybb, because at ybb only we need to calculate. Here in second condition, if you see, we need to calculate the moment. So we have taken the deflection at yxa, and next moment means we are going to apply a rotation. So only we are considering theta AA. Remember this, and don't forget, if we want to force, then we need to use displacement by displacement. That is displacement at x distance by displacement at the required point. If you want the moment, then we can say that displacement at x distance divided by slope at the required point. So again, if you draw the diagram, then that is we need to draw the influence line diagram. So we can say that 0 at both the ends. Next, if you mark the every point, so at 1.5 we can say that this is 1.5, 3, 4.5, 6, 7.5, 9, 10.5, 12. So at 6 we are having the value minus 2.250, next 2.285, next we are having 1.969, 1.230, so it will be 0. Here if you take, the value will be 0.738, 1.41406, 934. So if you join this, then the diagram will be like this. So this is how you need to draw the influence line diagram for MA. This is ILD for MA. So this is the method to calculate the influence line for indeterminate structures. Don't forget, we need to consider displacement by displacement for reaction, and we need to consider displacement by slope for moment. If you have any doubt, feel free to contact me. Thank you.